Alright students, so we are now starting with the next part of the chapter, which involves the numericals regarding the latent heat capacity. Alright, so starting with the first numerical of that as numerical first. So the statement of the numerical is 1 kilogram of ice at minus 10 degrees Celsius is heated at a constant rate until the whole of it vaporizes. How much heat is required? Specific latent heat of fusion of ice is 336 into 10 power 3 joule per kg. Specific latent heat of steam is 2268 into 10 power 3 joule per kg. Specific heat capacity of ice is 2.1 into 10 power 3 joule per kg per Kelvin, and specific heat capacity of water is 4.2 into 10 power 3 joule per kg per Kelvin. Alright, so these are the specifications that they have given. That is, mass is 1 kg. Ice is initially at minus 10 degrees Celsius. We'll see how the phase is going to change. Latent heat of ice is given, latent heat of steam is given, then specific heat capacity of ice and specific heat capacity of water is given as this. So now, what we have to see, first of all, the unit system. The mass is in kilograms. Each and every value they have given us in kilograms. So there is no need of doing any kind of conversion. So this is the statement of the numerical. Now there is a line in this numerical which says that this ice at minus 10 degrees Celsius is heated till all of this is vaporized. Means all of this has vaporized. So what is the changes which is going to be? Let us see in context with the temperature, and then we'll see the phases. First of all, ice will change its temperature from minus 10 degrees Celsius to 0 degrees Celsius. Alright, the ice will increase its temperature to 0 degrees Celsius. Now it has reached to its melting point. So it will melt from 0 degrees Celsius to 0 degrees Celsius. Alright. Then the boiling will take, there will be the increase in temperature till 100 degrees Celsius, and from 100 to 100 it will boil. So these are the changes up till this. The question has asked up till this, till all of that has vaporized. So it will vaporize at this temperature. Now let us see what kind of substance is there. From minus 10 to 0, all of this is ice. From 0 to 0, it is ice plus water, which means the melting is taking place. 0 to 100 is water. Here is water plus vapor. Water plus vapor, and after this there will be all vapor. So all of it has vaporized. Now we know whenever there is this combination where there is ice and water, or there is a mixture of two states, we say at that point of time the change in phase will happen. And during change in phase, we know that latent heat is used. So it is quite clear what kind of formula we have to apply. What they have asked in the question, they have asked the total heat required in order to increase its temperature from minus 10 to 100 degrees Celsius, or till all of this has vaporized. So all of it will vaporize till 100 degrees Celsius, starting from minus 10 degrees Celsius. So they have asked this Q. What is this Q? This is the sum of this heat, this heat, this heat, and this heat. So sum of all the heats will give us the total heat which is required to heat the ice till all of the ice has vaporized. So we know when there is increase in temperature, there is the formula as mc delta T. Then 0 to 0, there is latent heat, so m into L. 0 to 100, again change in temperature, mc delta T. 100 to 100, change in state, m into L. Alright, and sum of all these quantities will give us total heat Q. Sum of all these quantities will give us total heat as Q. So let us now see. One thing which is common is mass of the ice, which is 1 kg in each and every case. So how can we write down this Q? This Q will be written as m into C into delta T for ice. All of the things will be ice. then plus m into L. This latent heat is also for ice, so m into L plus mc delta T. Now all of the things has converted into water, so this is all for water. Alright. Now this is again m into L. This is for the steam. Alright. So this is for ice, then the latent heat for the ice, water, and then latent heat of steam. This is how this thing will going to be. So let us see. Mass is 1 kg. C of ice they have given us 2.1 into 10 power 3. Change in temperature. This ice is minus 10 to 0, so change is 10. First equation plus mass is 1, latent heat of ice is 336 into 10 power 3 plus mass of water is 1, C of water they have given 4.2 into 10 power 3. Change in temperature. Now we have reached over this part. So 100 minus 0, that is 100. Last part is mass of steam, again 1 kg into L for steam they have given us 2268 into 10 power 3. Alright. Sum of all these heats will give us the total heat required to change its temperature from minus 10 to 100 or till all of the ice has vaporizes starting from minus 10. So after solving this, we will get the answer as 3045 into 10 power 3 joules, and instead of writing 10 power 3, we can also write 3045 kilojoules. Alright. So the total heat required to make it all vaporize starting from minus 10 degrees Celsius is the sum of all the heats. First heat is to increase the temperature till 0. Then is melting, then is to change its temperature to 100, then is boiling. Alright, so that is how we have put all the required values at the required points, and the final answer that we are getting is 3045 kilojoules. Alright, so this thing is very important. You will have to see in what stages the change of the phase is going to happen. So this was one numerical. We'll now start with the other numerical. Now starting with the next numerical, numerical number 2. And the statement says, a vessel of mass 100 grams contain 150 gram of water at 30 degrees Celsius. How much ice is needed to cool it to 5 degrees Celsius? Take the specific heat capacity of the material of vessel as 0.4 joule per gram per Kelvin. Specific latent heat of fusion of ice is 336 joule per gram, and specific heat capacity of water is 4.2 joule per gram per Kelvin. Alright, this is what statement says. There is a vessel. In vessel there is water. This water is at 30 degrees Celsius. Mass of vessel they have given, mass of water they have given. They have asked for the mass of ice that must be added in order to cool down the temperature to 5 degrees Celsius. And all of these specifications have been given. The specific heat capacity of vessel, latent heat capacity of ice, and then the specific heat capacity of water. They have given all these specifications. Now again the thing is, the water is placed inside the vessel. So whatever the temperature of the water is will be the temperature of this vessel also. Alright. So we have to find out what mass of ice must be added in order to make the equilibrium temperature to be 5 degrees Celsius. Again the equilibrium temperature is here. So it means heat gained will be equal to the heat lost. Now the thing is, what are the things which is going to gain the heat and what are the things which is going to lose the heat? So heat will be gained by ice. Heat will be gained by ice. Now, ice is obviously at 0 degrees Celsius. The ice is at 0 degrees Celsius and we have to increase its temperature to 5 degrees Celsius. This is ice. So, what is the phase change is going to take place? From 0 to 0 degrees Celsius, the ice will be converted to water. The ice will be converted to water, and from 0 to 5 degrees Celsius, we have to reach this temperature which is the thermal equilibrium temperature. So at this stage, we can write down the melting will take place or the fusion will take place. From 0 to 5 degrees Celsius, there will be the increase in temperature. We know whenever the phase change is going to happen, there is no change in temperature and the latent heat will be required. So this requires M into L, and this is 0 to 5 degrees Celsius change in temperature, which requires M into C into delta T. Alright, obviously this is from water to water. So heat gained by the ice will be taken up in two steps. One is the latent heat, other one is the specific heat of water. So in two stages, first the ice will convert it into water, and then water will increase its temperature to 5 degrees Celsius, which is the equilibrium temperature. So we know heat gained by ice is equals to M into L for ice. When this has done, it has all completed into water, plus M into C into delta T for water. So this is how the heat will be gained by ice. Now, next is heat lost. Heat lost will be equals to heat lost by water plus heat lost by vessel. So these two things will be going to lose the heat. First is the water and the next is the vessel in which this water is being placed. Alright. So what is the heat lost by water? Heat lost by water is mass of water. Let it write in the form of the equation. Will not put any value till here. So it is mc delta T for water plus mc delta T for vessel. Because there is no change in state, there is only a decrease in temperature from 30 to 5, here also from 30 to 5. Alright, so heat will be lost by water and vessel, and heat will be gained by ice in two stages. First is the melting, and then will be the increase of temperature till thermal equilibrium is acquired, or this thermal temperature or equilibrium temperature is acquired. Now, because this equilibrium temperature is acquired, means the law of calorimetry or the law of mixture will apply, which says heat gain will be equal to heat lost. So heat gain will be equals to heat lost. So let us just put the values over here. We want to know here the mass of ice. We want to know the mass of ice. So let it be here. This is mass of ice, which we need to find out. So we'll not put the values of M over here. Rest values we know. Let us now put it over here. Heat gained equal to heat loss. Let us first put the value of heat gain. So M we don't know. Latent heat of ice is 336. So M into L plus mass is same because this ice has converted into water. M into. Now this is water. So specific heat of water is 4.2 into. What is the change in temperature? 0 to 5. That is 5. Alright. So this is the first equation. Second equation will be M of water. Here we know mass of water 150. Specific heat of water is 4.2. Change in temperature is 30 to 5. That is 30 minus 5. So it is 25. This is for water. Plus mass of vessel is 100. Specific heat of vessel is 0.4. Change in temperature is 30 to 5. That is 25. Alright. So here we know all the things. There will be left hand side, there will be right hand side. The left hand side will be in the form of M and the right hand side is in the form of some numeric value. After solving this equation, the answer that we'll be going to get is the mass equals to, let us say, dash. Now the thing is, we'll have to find out the units. See, here the units is gram, here the units is gram. All these specifications are given in grams. So there is no need of conversion. We haven't converted anything. So the answer that we'll be going to get will be in grams. So let us see what the answer is. So after solving, the answer we're going to get is 46.92 grams. So this is the mass of the ice which is required to change the temperature till 5 degrees Celsius when this amount of water and this amount of vessel is at the temperature of 30 degrees Celsius and the ice was initially at 0 degrees Celsius. We'll have to maintain the equilibrium temperature of 5 degrees Celsius. Then how much ice is required? That is 46.9. Alright. So this was the second numerical or the second type of the numerical that is very, very important. So this was all about this part of the chapter, and this comprises the end of this chapter. Any of the doubts, if you are having any doubts regarding either the previous concepts or this concept, feel free to ask that doubts in the comment section below. Thank you.